I think indeed this must be the longest title I have ever proposed for a talk, and it's a title that I would never let my students pass with. So this I would, okay, cut it in two, and even half of it is already too long. But just as an excuse, I have become a bit schizophrenic. So I was invited by Catherine to give a talk. So this is a talk at ENAC, at EPFL, which means I should talk about my lab and my research. And yet, the idea was to invite me to give a talk that is actually about my other life, the life that has started a few months ago at a theoretical 20% and more formal 80% since a week ago. So hence this attempt, somewhat inelegant attempt to try to actually make sense of my academic journey so far. And so let's just quickly go through that academic journey so that I can try to extract what I need from it. So, of course, as maybe some of you know, I had studied physics, then I did an Erasmus where I met my husband, which was probably the best investment of time in my life. I went some time to Berkeley. At MIT, where I did my tenure track, I went from focusing a lot on optics aspects of daylighting to more human aspects when I started to work with the Harvard Medical School. Back at EPFL, this time as a professor, I launched the LIPID lab, which then had this triangulation between comfort, perception, or emotional and health aspects to light. And as dean, I was also very happy to indeed embark EPFL together with 3 other institutions on the Solar Decathlon adventure, get the Smart Living Lab not really out of the ground, but on the ground since 2013, and then, of course, get the skill out of the ground and become a new kind of culture of makerspaces at EPFL. More recently, after a little passage in Singapore, I also started to lead a project on the energy transition together with a new startup on consulting services for the psychophysiological effects of light. Okay, and then, yeah, last but not least, maybe I also started to wander into the more artistic realm of things to try to talk about science through an artistic lens. So, if we try to find some red thread, I also ask my students always to have a red thread in everything they do, maybe one would be interdisciplinarity. And indeed, this has been sort of driving my work, not to be hopping from one subject to another, but to try to have a deep grounding with the ability to connect to others, to be relevant in a given domain that might be at the interface between existing domains or be core to a domain, but with this ability to connect and speak the language of others, which started maybe most notably when I started to work with the Harvard Medical School and realized that as a physicist, it was not so easy to talk with a neuroscientist and to try to come up with a common research project, even though I thought we were pretty close. And then when you reach out to architecture or design, this becomes an even bigger bridge to build. So, trying to get to my new life, I tried to reframe building research in a bigger picture. Because what are actually the defining aspects of building research? I would say that it is inherently interdisciplinary, actually, so because it brings together physics and energy and design and human behavior and social, etc. It also is a lot about the design process, which is by essence quite ill-defined, spiral rather than linear. As scientists, we try to work on hypotheses and move on. In architecture, it's more like you test and you go back, you work with references. It's a very different, very interesting, different process, and it's all about what we need to be comfortable, what we need to thrive in our environments, and so on. So this is building research, and when we look at what global challenges really mean, they are also inherently interdisciplinary because we need to connect many different aspects from climate science to energy or emissions to vegetation and ecology. So all of these are actually very strongly connected, and there are difficult to find more ill-defined problems than the ones we are facing, as we know there is no silver bullet that will be able to solve it all. In addition, sort of address these big challenges, it oftentimes is not a technological question or a scientific question. The resistance to change often comes from society, the societal structures. So what people are used to do, what people want, how people have been used to behaving. And therefore, we are facing this moment where we know what we should be doing, but don't quite want to do it. This is the cognitive dissonance. And also with these sort of contradicting messages that both in ourselves and from the outside we get to try to adapt to a changing world. Now, second challenge was to try to make sense of this for daylighting, which is really my core expertise. And so I tried this time to reframe, it was a challenge to give a talk, to reframe daylighting into one of the big transformations that we are currently experiencing, which is the emergence of AI. And if I think about both how building research or daylighting research, the pillars it relies on, and what can relate to artificial intelligence, we can find maybe more, but 3 pillars. The first, what I call information, is the fact that we need data and knowledge about things, whether we measure it, we simulate it, we calculate it. So we need access to the knowledge, access to the information. That is something that we do in research and in daylighting also. Design is another very important component. So of course the first interpretation we have of design is maybe, especially at ENAC, is maybe architectural design, so designing shapes and forms and buildings and works. But actually design in many other fields also applies, the design of an experiment, the design of a protocol. So all of these also require this concept of designing something. And there is the question of action. What do you do with it? How do you actually have an impact and then make changes happen afterward? And I liked the idea to have AI and BI together, BI for biochemical intelligence. I've never seen that written anywhere, so, but I like the fact that we are actually thinking now, or should be thinking about a partnership between artificial intelligence, alien intelligence, and biochemical intelligence, sort of organic intelligence. This intelligence should be serving the greater good, and therefore, in other words, human environmental well-being, which, as we know with the donut model, should be above social foundations to have sort of well-being there, but be below an ecological ceiling to not destroy the planet at the same time. So this allowed me to frame things in a bigger picture, and if I now am more sort of focused on how this can be interpreted in a way that I can bring my daylighting research in, between design and information, you can think of multisensorial environments. So the fact that it is a very complex, how we sense the environment is very complex, and therefore maybe AI can help us. On the other hand, because it is so complex and because the decisions we want to take or how we want to advance are so inherently ill-defined, we usually work with huge amounts of data, large data sets, and this also is where AI can prove very useful. And then this connection between design and action for me involves social dynamics, not only the resistance to change, but also in general how people would behave, whether it's in a building, in an open space, between buildings, in nature, whatever, or socially, is also part of the complexity, I would say, that we have to deal with. So now let's try to make a move to what this could mean in the research that we do in the lab. For example, in terms of multisensorial environments, we would work, or we have worked, on this sort of interrelationship between thermal comfort and visual comfort. So between the fact that if we are in a lit environment that has a certain color, we may or may not experience the temperature of that space differently, just because of the color of the space. So something that shouldn't, at least we haven't learned that it would happen, that we would experience it differently. And yet, getting people to experience different colors and different brightnesses with the same, with a given temperature and then another temperature, we found that actually, yes, there is an effect of what we see, of the color or the brightness of where we are on our perception of temperature. So not on the temperature of the room. This is not what I'm talking about. I'm not talking about solar gains going through a window that is more or less transmissive. I'm really talking about a given temperature, but how you feel. And actually, in a building, the only thing that matters for thermostats and energy savings is how we feel. It doesn't really matter what the temperature is. What we really want ultimately is to have people comfortable. So we can see in these results, for example, that when the temperature of the room is cold, we feel cold. When it's warm, we feel more warm. Okay, no surprise there. But when it's comfortable, this is where there is a slight influence of the color of the light, or in this case, the color of daylight, which when it's blue, we tend to feel a little colder than when it's red. And then for brightness, it's more probably about expectations. When it's cool, we usually prefer a little bit a brighter space, whereas when it's warm, we usually prefer a little bit of a dimmer space. On the data sets and ill-defined contexts, an example would be coming from circadian rhythms and neuroscience. So this is a collaboration I've established now 20 years ago. And the idea there is to look at how much light impacts us physiologically through our eye. So our eye is the channel through which we detect light, as you know, but not just for vision, which pertains to cones and rods, but also through another photoreceptor that was only discovered 25 years ago, which is amazing these days to discover something so fundamental very recently. And that photoreceptor called melanopsin, or IPRGCs, is responsible to entrain our circadian rhythms and basically to synchronize our biological clocks. So it is through the light in our eye that we do this synchronization. Now, what does this mean? It means that depending on your light hygiene, depending on how much light you get at what moment of time, you will have different physiological consequences. And these usually are not instantaneous. It's not like if one day you have a certain hygiene, then you're doomed or good for life. But it's something that is slow and sort of builds up over time. And so to look at this building up over time, we need to look at light on an individual basis. It's not enough to just see how much light there is in a space that we would inhabit, because the behavior has so much impact on actually what this light does to us. So if we follow theoretically someone living his or her life, in this case in Berlin, we can see that at every moment of time, the exposure of that person has a certain spectrum, so a certain distribution of colors that they see, and a certain amount, of course, a certain brightness, and sort of a difference, and this is the blue versus the white, a certain difference between what the photoreceptor sensitive for circadian rhythms, the melanopsin, would sense versus our cones, for example, which is for vision. And so going through this, we can see how much this accumulation of the light that we have over time might affect ultimately our physiology and therefore our well-being. So at every moment, there is a different spectrum, and actually the melanopsin photoreceptor is more sensitive towards the blue, and therefore we can see, okay, but so how do we make sense of such a data set? Well, even without necessarily going to the deep end of artificial intelligence, we can try to collate all of this data and turn them into families, in this case with the k-means method. And so once you have families, you can start to say a lot about someone's life. You can determine in what family that light exposure was at a given moment of the day, and then you can say a lot about their life that day. The fact that they commuted in daylight, probably either by bike or on foot. They had lunch in a fluorescent lighting space, so if we know where they work, we probably know where they had lunch. That they have a kind of 3,000 Kelvin lighting at home. Maybe their bed lamp is a fluorescent light, not so good, and so on and so forth. So you can learn a lot just from the light hygiene, and therefore, after that, deduce implications on sleep and melatonin production at night and new rhythms and so on. So we have worked also with shift workers, and then, then of course, you see a lot about the desynchronization. The third example, which borrows from the affinity map that some of you might still remember, that has now turned into bags that I still use anyway. It's also interesting to see social dynamics in such a context. So I think people would be drawn first to their own home, in this case a lab. So I suspect that the little group of 4 people over there is probably affiliated to the wire lab, to Fernando's lab. This is just an assumption, but this is what would be natural. But anyway, in terms of social dynamics, maybe a good example of that is the SWICE project funded by the SFOE, which I led for several years, now taken over by Philippe Tanman, together with Luisa Pastore. And the idea there was to look at people as the agents of change and at different aspects of living, mobility, open spaces, built spaces, and overall energy as where this change should happen. The change should happen by resisting less to change, and so the whole project is based on social dynamics and on trying to change the mindset of people, testing in pilot projects small changes that would serve the energy transition. And so the whole frame of that project was to ultimately get to policy changes, to stronger methodologies when it comes to evaluate real environments, like living environments, as well as getting more tools in our hands to make decisions. Okay, so now if I zoom out and I look at this triangulation, we should not forget that it's a lot about staying aware that our world is not a world of data. This is only a representation. Our world is also physical. So our interactions are also physical, human to human, with an exchange of energy that cannot be replaced by Zoom meetings or any other meeting, but that the digital helps us represent it. We should also not forget what gives us a sense of purpose. This was a moment in the Solo Decathlon. You can see this drive, so we need that. We need to struggle, we need to learn, and then when we achieve something difficult, there is this reward that is magical, I would say. And also where we came from. We come from a planet that revolves around the sun, that has a 24-hour cycle, day and night. We have evolved over millennia, millions of years, billions if we take it from the very beginning of the Earth, and this is not to be neglected, that this is what we have grown, if I can say that, in sync with, and therefore cannot be just put aside to be replaced by digitalization. But so what we really want is embracing a new type of connection, the connection between fields, the connection between us, also be open to solutions that maybe AI would bring us and therefore are unexpected, the famous move 37 in AlphaGo, and that we don't yet know all the processes or what awaits us, but we need to remain in charge of meaning and of ethics and not outsource these aspects. This is really our responsibility. So now that I've framed my work into a bigger picture, let's go to the bigger picture and my new life, my other life, as head of the JESDA Science and Diplomacy Anticipator. So it's a mission that when I started, it was hard to understand because it is multifaceted and complex, but now I have started to sort of digest that complexity, and I did exactly the same thing as I did with ENAC when I started as dean in 2013. I tried to draw it, to make sense of it by giving it a shape. And so this is what I did with JESDA. So first, to frame the question asked. The question asked is, that currently we see a sort of a incremental but quite rapid collapse of global cooperation and of multilateralism that are not anymore the default way of working together at an international level. So this is very new, because it was always the default plan, the one that everybody should agree to, and now it's not anymore. And yet, at the same time, we know that the challenges we are facing are global in nature. They are like climate change, public health, all of these, human rights, all of these are vastly global, like they're really inherently international. And therefore, what is really difficult is that when we see that fragmentation increases, this goes against solving these challenges, at the same time as the trust in institutions decreases as well. Now, if you look at scientific breakthroughs specifically, we see an acceleration. We see that the transformation that is happening is strong, quick, and always bigger and faster. And therefore, the problem is that we need to collaborate because the challenges are global, but at the same time, because it's going fast and because there is a lot of interest to be ahead of the game, competition increases in parallel. And this makes action very difficult. And so our work has been, or that was really their work, has been to try to work on reconciling these antagonistic movements in, for example, looking at global governance issues or questions or agreements, as was the case for the UN Pact for the Future. In addition, there is a question of speed. It goes fast, and institutions are slow. And it goes fast with a lot of promises, a lot of advantages to being ahead in the race, and therefore geopolitics start to be driven by scientific breakthroughs. This starts to drive those, the geopolitical thinking, like is the case with AI for the moment, where there is this race to AGI, artificial general intelligence. So this is problematic because our institutions have a high inertia and are slow. And so that means we need to both anticipate, so be prepared, but also be agile enough and try to work towards a collaboration. So if we summarize GESDA's mission into as few words as possible, it is all about scientific anticipation. So the idea is to try to see what, or foresee, so to speak, what science has in its drawers in the years to come, in 5 years, 10 years, 25 years to come. To do that, it's not enough to look at publications, because this is usually a work that was already done a few years ago. It's important to talk, actually, with scientists. And so we have a community of almost 2,500 scientists across the globe with whom we work to have workshops and go deep into the specificities of these scientific breakthroughs and what is coming. So it's about seeing what is in the future for when it comes to science, without telling diplomats or anyone what to do about it, but equipping them with that knowledge and accompanying them in the decision-making process. So this is anticipation. In addition, we want to act. So we want to not only think about what is coming, but then show that it is worth doing something about it early on, especially because once we are in the race, like we are with AI today, it's too late, a bit late or stressful to be thinking about safeguards, regulations, new governance. This is hard. There was an attempt, I think it was a couple of years, well, in 2023, when AI suddenly became democratized, like we all could get access to it, there was a push of scientists to say, stop, let's just take 6 months, and this didn't work because there were commercial interests already there. So this moment of let's stop can happen if we are doing this before the race has begun. So this is really the thing. So to act and then to prepare infrastructure, to prepare alliances, coalitions, partnerships when it's still time, knowing that there is an acceleration between the two. And so how this should be done is by making different communities talk to one another, especially the academic community with the diplomatic one, so the one that is making these decisions at an international scale. And this is in our role of honest broker, which is about bringing the people the actors that are relevant for a given question around the table. And this also extends to the private sector and, of course, the citizens that we all are. And these are the 4 communities that JESDA is working with. So our core mission is to do science anticipation, as I said, and the format that it takes, or the most recognizable format that it takes, is called the radar. The radar, as you can see with the 5 colors, is split into 5 domains. The domain of quantum and advanced AI, the domain of human augmentation, these are the titles that were given several years ago, eco, regeneration and geoengineering, science and diplomacy, and knowledge foundations. But the point of that radar is to try to identify a limited number of key topics, around 40, each year, that are sort of representative of emerging science, and follow them through, and then go into the nitty-gritty details, really going deep, both in timescale, 5, 10, 25 years, but also in topics. So if we try to re-talk about these subjects, we can realize that they are all about transforming how we live. So it's either about who we are as humans, really the nature of human beings. This would be what I would reword as the mind and body. How we live together, so this really pertains to societal structures in yellow. How we interface with our planet, with the natural environment. This is in the light green. How we represent our world through our information systems, and the fundamental knowledge that brought us here, which I could reword as foundational knowledge. So this is really how the radar is structured. And it's about seeing, okay, what is coming up in 5 years? Well, quantum computing is a good example of it's already emerging, but it's not quite there yet. It's not commercialized. It's still prototype stage. So it's still time to act. In 10 years, we go from almost reading our thoughts in mechanical way to being more intrusive, in the sense of being more connected to the AI and or computers, and ultimately maybe to change our own biology and genes. And then in terms of the environment, this can also extend beyond the Earth system to the stellar ecosystem. So one example of a concrete project that we have launched 2 years ago, of course it wasn't by me, it's called the Open Quantum Institute, in an overall initiative that's called Quantum for All. So the whole point of these kinds of sort of developments is to show that by knowing what is coming up with quantum, we can equip especially the more sort of underserved economies by working with them on forming alliances, coalitions between foundations, the government, possibly other countries, the World Bank. So entities that can help to build the infrastructure with them to be ready when the time comes, when the quantum computing will be there, to act on very specific topics that are interesting to them, which we decided to seek along the SDGs, the Sustainability Development Goals. And with a method that is about governance, that is about access to all or broader access, and to know what to do with the information that we have from the science. This, in theory anyway, can be deployed in other domains, and for me the whole point of this is to show that it is the method that counts. It's the fact that we need to bring people together around the table, work on the governance, work on the key questions, like with the human-computer interface. This would be, how do you deal with people, like entities being able to read your thoughts? How can you deal with the fact that we are permanently connected to an alien intelligence? So all of these questions are really fundamental ethical questions, and we should ask them now before the technology is on the market, and there the end change and might change us forever, really. To enable this, we need to know how to act, and this is what I call the capacity building aspect, which is about equipping us with the mindset able to anticipate, able to do something about this early information and know in our own sphere of influence how to act. So different examples of that are activities we already are working on, like the JESDA Summit, which is our annual conference that allows us to bring about 1,000 people, diplomats, scientists, industry representatives, many different groups to talk and have debates and panels and discussions and workshops and all of that to talk about this scientific anticipation aspects. So this is very global. It is also has a nice convening power to get the actors around the table to talk physically in a place, and of course relies on a lot of partnerships. Another experiment we have launched together with EM+, the Laboratory of Serocandodyne at EPFL, is to translate the radar contents into a form that is more accessible to people like you and me, and therefore to make it into an artistic, emotional experience that allows to be immersed in an environment where you can imagine your own future by being told stories about a certain number of parameters that you choose and are extracted from the radar contents. We also try to have different entry points into the contents of the radar so that depending on who you are and what you're interested in, you could make sense of what all this information is about. And also this capacity building aspect that I mentioned before, so educating, giving training. These are usually intense weeks that we have started to give across the globe on getting people to engage in this anticipatory mindset, including through what we call the diplomacy games, which then you take the role of an ambassador or of a colonel, of someone who wants to say no to everything, and you sort of experience what it would be in real life to work on these subjects. So, to summarize, we can consider JESDA as a duality between a think tank and a do tank, to think ahead but also do something about it, as well as an entity that tries to build the capacity to act and also is convening the actors around the table to have these conversations early enough to be able to have an influence. So I didn't add a slide with all the pictures of all my teams. Now my team has more than doubled with JESDA, but I thank all of them, both at LIPID and at JESDA, for this amazing work and for allowing me to have this new adventure in parallel to EPFL. Thank you very much for your attention.